In this video, we'll take a look at error handling with respect to async event sources such as S3 or SNS. Lambda invocation in this case is event driven. You upload an object on S3 and event is triggered. Or second example could be you put a message on SNS topic and event is triggered. So during this type of invocation, if error occurs, there's no upstream caller which is waiting for your response, just like we have in case of API gateway. So this is async, so Lambda has more sophisticated error handling model in this case. So if an error occurs, Lambda first tries to process the events up to twice with some delay between the retries. And if these two retry fails, then Lambda can send the failed event to DLQ or destinations or both. So this retry would be there by default, and the option to configure DLQ and destinations has to be done by you. I'll give you a demo on the retries now, and then we can cover the DLQ and destinations. So I'll open my Lambda console. This is our Lambda function that we created in our previous video. So this Lambda is invoked on S3 put object. So if you go to configuration, and inside that you have an option for asynchronous invocation. Let's click on edit. As you can see here, you have option of up to 2 retries apart from the actual invocation. So there are total 3 attempts. You can configure this to be 0 or 1 or 2, and you can set the value to 0 if you don't want any retry. Let's keep it 2 for now and test it with the help of code. See what happens when our code fails. So for this Lambda, my code is in IntelliJ, and I'll open my Java code and let's throw an exception in our Java code to see what happens. So this is the class S3 event handler, and handle request is our handler. In this code, I'm just processing the CSV files uploaded to S3. So if you want to watch this video, I'll give link in the description below. You can check this video. I just want to see the retry behavior done by Lambda. I'll just comment this code and throw one exception here. I've added one log statement here, and then I'll just throw the exception. Let's package our code and deploy this. I'll go to my console, upload the latest code. Code is uploaded. To test this Lambda function and retry behavior, I'll just upload one object to the S3 bucket. To check the S3 bucket, click on here and you'll find the triggers, and you can get the details from here. You can see the event type is object created by put. I can open this bucket and upload the object. Click on upload. Just drag and drop your object and click upload here. It's success. Now let's go to monitor and click on view logs in CloudWatch to see the invocation. Let's open the latest one. I'll zoom it. You can see here we received the S3 event and exception occurred. Something wrong happened, like we added in our Java code. The initial call is failing. Now Lambda should retry this 2 times. Let's see when that will happen. Yeah, you can see that Lambda tried to process the S3 event 3 times. So first one is at 12:49, and then after 1 minute at 12:50, and then 2 minutes after the second event at 12:52. In total, there are 3 attempts to process an event that Lambda promises for an asynchronous event source. There's no official documentation on how much is the interval between these retries, and there's only one guarantee that this retry should be performed within the maximum age of the event. If you give here 2 hours, then Lambda will make sure that it retries the 2 attempts within 2 hours. That's it. And there's no guarantee, what would be the interval between the retries. If you don't make any further change, Lambda won't do anything after all the retries are exhausted. So you have the logs in CloudWatch and nothing else. Consider a scenario wherein you have implemented microservices architecture and you have multiple microservices depending on each other. Let's say that one of the service fails, then there should be a mechanism to let the other microservices know that this service has failed. Or you can say that you want to take some important actions which should not be missed in case there is some failure. For handling such scenarios, we have further two options, dead letter queues and destinations. Let's check the DL queues first. So Lambda provides the capability of automatically forwarding events that fail all their retries to a dead letter queue. So this DL queue can be SNS topic or SQS queue. Once the event is in SNS or SQS, you can do whatever you want with that. You can either process that immediately or you can do it manually later, or you can write a batch process which processes all the failed events at a particular point of time. You can also create another Lambda function that listens to this SNS topic or polls the SQS queue and processes the failed event. Let's take an example how this flow will work. Let's say you uploaded an object to S3 and on S3 upload Lambda is triggered. And in case of failure, let's say you are using SNS as your DL queue, then you can have multiple options, right? You can write a Lambda function that processes this failed event. You can also add a subscription to email or SMS so that your team can get to know that there is some failure with respect to some event. Or you have other options which is given by SNS, for example, using Amazon Kinesis Data Firehose, or you can use custom HTTP and HTTPS endpoints. So this is up to you. You can do whatever you want to do with your failed events. There are three things which you need to keep in mind when you are creating DL queues. And the first step is to create a new SNS topic or SQS queue to act as DL queue. In our demo, we would be creating a new SNS topic as DL queue. Second step is to configure Lambda function to use the created SNS topic or SQS queue as a DL queue. And the third thing is you have to write a new mechanism to process the failed event. And in our case, we will be creating a new Lambda function that subscribe to the newly created SNS topic, which is acting as a DL queue. So these are the three steps that you need to take care. Let me demo you all these three steps. So the first is create a new SNS topic to act as DL queue. I'll go to AWS console to create a new SNS topic. Let's search SNS here. I don't have any topic as of now, so let's just create one. I'll keep the settings as it is and I'll use the standard one, not the FIFO. And display name can be DLQ for S3 Lambda. Click on create topic. Now the second step is to configure your Lambda function to use this particular SNS topic. I'll go to the Lambda console. So in Lambda console, you have to go to configuration and then asynchronous invocation. Click on edit here and you can see that you have the option to configure DLQ. I'll choose SNS here and the topic should be DLQ, which we just created, and click on save. You should be getting this error because when we configure DLQ, Lambda would be publishing the message to our SNS, right? But we need to add the publish permission on SNS to our Lambda role. How you can do that? You can just go to your Lambda and in configuration, you can see there is a permission tab. Click on the role. You can see as of now we have two policies. First is S3 read-only access because we were processing CSV files, and second is basic execution role, which contains the permission to write the CloudWatch logs also. So in this, we have to add SNS publish permissions. Click on add permission, attach policies, enter. I will select SNS full access because this has permission to perform all the SNS actions. We are good to go now. Let's just go back to our Lambda and go back again to asynchronous invocation. Click edit. Then again choose SNS and select the DLQ. Now we should be all set. Yeah, we didn't get any error. The second step is done. So these two are done. And the third step is we will be creating a new Lambda function which would be processing the failed event. So I'll go back to my Lambda console, click on functions. I'll create a new function. I'll name this as DLQ processing Lambda. I'll choose Java 11 and click create function. Now Lambda is created, but for its invocation, we do need to add its ARN into the SNS subscriptions. I'll just go to SNS here, and you can see that for this topic, there are no subscriptions. I'll click on create and choose Lambda here and give the ARN of our Lambda. Click on create subscription. So now we have one subscription, which is our Lambda. So that means whenever a message is coming to this DLQ, it would be going to our Lambda function. Now if I go back to my Lambda function and I refresh this, we should be able to see SNS here, right? Because this DLQ processing Lambda would be triggered from SNS. Everything is done except the code that we need to write for this DLQ processing Lambda. For writing our code in Java, I'll go to IntelliJ. I'll create a new package DLQ and a new class inside that. I'll create a new handle method. And this handle method should be receiving SNS event. So I'll take this as first input. And I'll have context also. So the first thing would be Lambda logger. I've just added one log statement here, and then after that I'm iterating over the records and just printing each record. I want to keep this simple so that you should have better understanding. I'm calling toString method here for the record because this will print all the details and we can get to know what exactly are the details that we get in the failed event. So this is done. I'll just package this and deploy to my DLQ Lambda. Click on upload from and zip. So the code is uploaded. Now just go to runtime settings to update the handler information. Click edit here. I'll copy the package name from IntelliJ. Yeah, it's done. So now we just have to test our original Lambda, which is Lambda S3 event, and we have to upload the object to S3 to trigger this. And before going into that, let's just edit this retry attempts because I don't want my Lambda to retry 2 times if some failure occurs. So I just edit this and I can make this 0. Now what will happen is after the first failure event should go to this DLQ. So I'll go to S3. Click on upload. I'll drop the mock data here. Yeah, it's done. Let's go to monitor here and CloudWatch. As you can see here, event is received and it failed. Now failed event should go to this DLQ processing Lambda. And if I go to monitor here and click on view logs, yeah, you can see that we have received SNS event and we have the DLQ event. I'll click on view as text and let's zoom this. Yeah, you can see here we get all the details like what was the error message, something wrong happened. Then the S3 details like the bucket information, and the object information. So yeah, from this record you can get to know each and everything, and you can write your custom logic to fetch the bucket name and object name, and you can process this particular object. If there is any problem with the data, you can correct that data, or you can manually do the processing. So this was it from the DLQs. Now we can look at the destinations for capturing failed events in Lambda. So destinations, as the name says, as a destination for your Lambda, more powerful feature than DLQs, because here you have option to select services other than SNS, topics and SQS queues as your destinations. You can directly invoke your Lambda also, or you can send your events to Event Bridge apart from using SQS and SNS topic. So when you use DLQ, you have to choose SNS or SQS as DLQ. Then only you can invoke your error processing Lambda. But with destinations, you can directly invoke it. So apart from failed events, you can capture successfully processed events also. So this is really a good feature, because you can have a scenario where in case of success, you want to process some other event, or in case of failure, you want to process some other event. So you can do both the things here, not only the failure handling, which is the only feature of DLQ. Let's look at the example flow when we use destinations. Let's say you upload a file to S3 and that event triggered the Lambda function which failed. When it failed, we can configure destinations which can be of any of these 4 types. You can add multiple destinations also. For example, on success, you want to trigger successful operation, and on failure, you want to process the failed one. So this can be tweaked as per your use case. This is the image from official AWS website. You can see that we can have multiple sources for our Lambda function, and in case of success, you can trigger maybe another Lambda function, and in case of failure, you can drop your message to event bus in Event Bridge and do the further processing. So this is really convenient in case of destinations. Let's now jump to the demo part, wherein I can show you how you can add destinations for your Lambda function and how you can process the destination events also. I'll go to my AWS console. So I will use this existing Lambda function, Lambda S3 event, which is triggered on S3 put object. Here you can see the option to add destination. Click here, add destination. Now you have 2 options for the source. If you want for the synchronous invocation or stream invocation, for example, Kinesis, in my case, this is S3 put, so this is a synchronous invocation. And condition is on failure or on success. I want to process only the failed events. I'll keep this on failure option. Now the type can be SNS topic, SQS queue, or Lambda function, or event bridge, event bus. So I can choose Lambda function here. Here you need to provide the destination Lambda function. Let's go to functions, and I'll create a new Lambda function which will be processing our destination event. I'll click on create function. I'll name it as destination Lambda. I'll choose Java 11 and click on create function. This is the name destination Lambda. I'll just go back here and click refresh. Now you have this option of destination Lambda. Click on save here. You can see here your function execution role doesn't have permission to send the destination. That means our existing Lambda function has to invoke this new Lambda function. So this will automatically add a new permission for this. If you try again to click save, so this will automatically add the new permission to your existing role. Yeah, so this is done. You can see here our Lambda S3 event function has the source as S3 and the destination as AWS Lambda. In configuration, you can have the destinations also. Source is a synchronous invocation and condition is on failure, and ARN of the Lambda is this. Now our destination Lambda is created. We have to add the code for this Lambda because we want to process the event which we receive. So for this, I'll go to the IntelliJ and create a new class. I'll create a new handler here, public void handle. So source for this handle method would be a Lambda destination event, which you can find in Lambda Java events library. So if I open this, I'll show you the class which should be acting as our source. So this one, so lambda destination event, we will be using this as our source. First I'm printing that we have received the event, and then I'm printing the details about request payload of our event. So when we talk about destination event, this is the invocation record example. You can see that we receive all these details from destination event. Request payload contain all the details about our event. So I just want to print this and see what all details that we receive, and then we can take further actions from the details of our request payload. So this is for the example purpose, guys. You can just play around this event. So I'll just package this and upload our code. I'll just save this. We are all set to test our lambda. Let's just go to lambda s3 event function and just verify. Yeah, we have this lambda. We have also the DLQ, you can see here. So in this lambda function, we have both destinations and DLQ configured. For testing, let's go to S3 bucket and upload one object. Yeah, it's done. Let's go to monitor of the original function. Click on view logs. Yeah, we have received the failed event. Now let's go to destination lambda, click on monitor, click on view logs. Yeah, you can see here we have received the destination event. I'll click on view as text and I'll just zoom this. So this request payload contain records, and in records you have details like S3 object, you have bucket name, you have object details also. So with the bucket name and object name, you get the details about problematic event. So you can choose when to process this event, if you want to do it immediately or at later time. This was all about destinations in AWS Lambda. So if I go to my original Lambda, you can add multiple destinations also. Let's say if I click on add destination, I can do it on success also. Choose whatever I want to do with success case. So this is really convenient and a better option over DLQs. So this is all I wanted to cover in async event error handling.